Let's have a really short Lewis structure review. So when we're drawing Lewis structures of these organic molecules that we're going to be talking about, you're not going to panic too much. First of all, very important to know that we will not be violating the octet rule in this class. We will not have formal charges. We will keep things as straightforward to the octet rule as possible. And that means when you are putting together molecules in this class, there are only 3 atoms you have to worry about: a carbon, a hydrogen, and an oxygen. And in order to maintain a 0 formal charge, carbon will always get 4 bonds and no lone pairs. If you ever draw a molecule that has 3 bonds or 5 bonds around a carbon or has a lone pair, you're wrong. Just make sure that every carbon gets 4 sticks coming out of it. Hydrogen only has 1 electron, so it is always going to just have 1 bond and no lone pairs. In order to get a formal charge of 0, oxygen will always get 2 bonds or 2 sticks and 2 lone pairs. Just to remind you, that makes these atoms sp3 or tetrahedral, but we are not going to worry about the 3-dimensional structure of these molecules. We are only concerned with their connectivity. That being said, sometimes you are given just the chemical formula. This molecule contains 3 carbons, 8 hydrogens, and an oxygen. But that does not specify its structure. You can draw a number of different isomers, or structures that have different functionality. For example, if I just stick 3 carbons together, you can see that each of these carbons now has 4 bonds. I can put hydrogens on the outside of them. Now I've used up 7 hydrogens, but I have to use up 1 oxygen. So if I just put the oxygen in there and stick a hydrogen on it, you'll notice that all of the carbons have 4 bonds. All of the hydrogens only have 1, and the oxygen has 2 bonds and 2 lone pairs. I could have drawn that differently given that chemical formula. I could have done it by sticking an oxygen right in the middle of the chain, and then put hydrogens. All around it. Both of these are correct Lewis structures for this chemical formula. Sometimes the isomers can be designated using what is called a chemical formula or a structural formula. So I'd have C3H7OH. This shows that this particular structure contains an OH that are bound together, which would be different than this structural formula for this isomer. Both of these contain 3 carbons and 8 hydrogens and 1 oxygen. Both have the same chemical formula, but they have different structural formulas, just to give you an indication about what the Lewis structure would look like. Whenever we are drawing Lewis structures, you never are going to put an oxygen connected to an oxygen. This is an oh-no. It is a peroxide, and we're not going to be dealing with those. So don't make peroxides in this glass. We're dealing with some fairly simple structural compounds. So when we're drawing Lewis structures, please remember, all carbons are going to get 4 bonds, no lone pairs. Hydrogens get 1 bond, no lone pairs. Oxygen has 2 bonds and 2 lone pairs.